congratulations.
I should rephrase. I've written Joe's story, so I know how Joe's story is.
Does he die? Tell me it's an explosion.
Stay tuned. Summer 2017.
Oh, dude.
Let's see, this week will be quiz 8, and then 9, 10, 11.
Is it 12? No, dude, I just had this conversation with the class.
Don't
instigate.
Average again was pretty high. In the 80s. So, a lot of people doing well.
Yeah, what are you doing?
So let's just have a vote. No one knows batch distillation here, so let's start from the very beginning.
Right what it looks like?
No one knows what batch distillation is. So.
This is so deep. This is good stuff.
So it's just a Rayleigh still with plates. You also have your L and not D. V. And your L behind your.
You have D, right? Like D is the flow into the T.
Yeah.
Because you
yeah.
have reflux ratio.
Right.
Sure.
So V naught is the initial amount of oil
Yep.
you have?
Yeah.
And then, so the Z is your initial amount?
Right.
Okay.
For D, is that XD average or is that XD? Will the concentration change?
Oh yeah. Good call. So that's the important distinction you have to make. So these, this is like the time average of everything of D and XD.
So the D is the flow.
Yeah, D is the flow rate, T is an amount.
It's the amount.
So for each of these problems, I liked on the quiz, like the past quizzes, do you kind of want to use the Rayleigh still and then find like what that integration should be using the Simpsons rule? Is that kind of?
Yeah, so you can write the same equations for that you did for Rayleigh still for this. Let's try that. But I'm not going to write it down. I want you guys to try it because we're getting to the point where you should be able to do some of these yourself. So remember from the Rayleigh still, this is what it looked like. Remember that stuff? So it's the same thing. Just try it with your groups. We'll take 5 minutes and we'll try and see if we could derive something analogous to this. talk to each other, collaborate.
No, you don't have to. Oh, you do have to.
That's kind of where you start out, right?
B plus L. Yeah, but what about concentration?
Oh.
Because you have liquid coming in the drain, you can't just say that negative dVdt liquid. That's changing the volume of the tank. L has to be XD also. So it would be negative dy or L. Right? That's what?
Yep, cost. No, there's a reflex ratio, just like with distillation.
Is that the same thing that happens? LXD minus V or
Yeah, and Bx is a function of the time.
That Y, would that Y instead be XD? So
Yeah, in the end it has to be.
DXD, DXB,
yes.
DXD would be negative X. D?
Yep, keep going. I think we're on the right track. Andrew.
So, first problem, L will equal L prime, so B will equal B prime, well, is that B prime a lot? B will equal B prime?
Yeah, but that, if you do that, that doesn't get you much.
Okay, and then, so the reflex ratio is L over D as well.
Right. Reflex ratio is the same.
What's difficult to, you know, for the Raleigh still problem, you wanted XD times E, but since you have a reflex, you do XD minus XD times L. So it's basically D minus L is percentage. Be the amount.
D minus L.
D minus L. Okay.
Well, all you have to do is change the Y to X.
Oh, okay.
Yeah, at any given second. Yeah, because delta B is
Yeah, so it's just like makes the same thing. I think.
negative D, negative B. Negative D.
Yeah.
And then you change D out of DT to D.
Like, you don't change it.
Is that what you did?
Well, I think you would do.
Like, it is really still, except for Y is XD.
Oh, well, post rate is just rate.
Well, I don't think you know why. I don't think you don't know.
Anytime you change an XPB, but do you have to account for
Y is
L
XD.
coming out?
No, because why depends on X, so you don't know why.
This is next.
As long as we assume that.
Well, this is where you're supposed to get.
Yeah, as soon as
Yeah, that makes sense. XP
Is that how this is working? Or are we just assuming there's no whole
XD.
So then, yeah,
This is
what's
your
boiling
bottom
at the
line.
bottom has to be
But
right,
your,
no matter what.
your left side, you're integrating
It
over
should be
like
that BX accounts already for the left side. Well, are you sure it's negative X?
That
Or
is,
that's negative Y, right? Because XD,
You're going from initial to final, and that's your final.
it's a total convenience. So is negative, or is Y equal to DXD?
XD.
Yeah.
Yeah.
Oh, LXD plus it would be YV would be equal to L plus 2.
Graph.
It has to be. Like, Vy has to be equal to L plus D. Because
So you have to do this, and then you have to take your own graph, and make your own graph.
No, wait,
So you have to make, yes. So basically, you're integrating from, in this case, it says,
Yeah, so
you want to find
but
purity.
I can't say that this is true with concentration of XD.
The XD is 0.25.
All right, let's come back together. Somebody from the back, tell me where to start.
Because it's what's going on.
Right?
Yeah. Well, no. So that was for Rayleigh still. I want to do the same thing, but for this. There's different variables.
All we do is would change your L to be V with also the shift on one thing. You go from D0 to D, V over V.
Okay, that looks okay.
And you start off with your multiplication by Z. So on the other side, your integration limits stay the same as well. These are XD up top.
Wait, why do you have XD on the top?
Because that's what's coming out of the, that's what you
Right, so remind me here, was this right? Is this the right limit of integration for the Rayleigh still, or is
No,
it?
you're right. It's supposed to be bottom of top. So it should be XD.
Okay.
I don't see why the actual part being integrated would change by the argument from the change.
So it should still be this?
Yeah, I guess if we could plug in, you always solve for alpha equals 2.
How do you deal with the multiple stages? So what's Y?
XD.
All right, why is it XD?
Is it just from the final component that's going in
Well, yeah, but you can't just look at it and say, oh, the limit should be
Totally
XD.
condensed, so all the paper goes to.
Right, that's a good point. So XD here is the same as XD here, or YD here. That's a good realization to make.
The same thing with the L, right?
Yep, L is at XD. Keep going. More suggestions.
But don't you have to account for the fact that L is coming back, like V is equal to L plus D?
Right.
Like, so
yes.
the change in the base volume has to account for the L that's coming back, like,
Would there be a second interval?
would there be a second?
No second integral. Okay.
It's a no, I guess, right? So you just get.
What is dV dt?
dV dt is L for, no, negative V. It's negative V.
Negative V prime.
It's
Negative
Yeah.
Andrew, you had it.
D?
Why? Yeah. Why is it D?
Because dV/dt is equal to V prime minus L.
Minus D.
Prime, so.
Because-
You said V prime minus L prime is the same thing as D minus L, which is D.
Right. So change in B over change in time. So just what's going on in here? You've got in minus out. L prime is coming in, V prime is going out. Because there's equal mole overflow, L prime is L, V prime is V. V equals L plus D. Therefore, this is the important one. So this is totally right, except it's not tractable because we don't know what, if it's not specified what V prime and D prime are, you don't know.
DJ.
Yeah.
You just say that for example, extra L and L prime always equal to V prime always equal, what you just said?
No, that's because of constant molar overflow, equal molar overflow.
Are we gonna do cases that aren't that?
No, it should always be a total condenser. So you should be sending liquid in. Okay, and then the other equation we need is dxb.
In the case of a batch distillation, are we gonna have any kind of condensing within the stages?
No. anyone remember the step that we take to do now?
Divide.
Yeah, flip one and divide it.
Yeah.
I'm gonna flip this one, divide this one by that one. Now what step do I take from here?
Separate out the USDD.
Yep, chain rule. Not the chain rule.
Yeah, probably.
Whatever rule.
Hand waving motion.
Fancy calculus. And what are the limits? Z and XB. And then reminder, if you wanted to be fancy calculus, you'd use squiggle, squiggle. Or do it different, or squiggle here. Hopefully that makes sense. Okay. All right, so that's fine. Now what? Well, I guess there is no now what, that's it. Like that's the design equation.
Well, except, I mean, you can go ahead and integrate the left side, but.
Yeah.
I don't think you would do that.
Yeah, that's easy enough.
But yeah, you don't have the right hand side.
On the right side, you use some rule.
Yeah, eventually. But what's the problem with the right side?
You don't know XD in relationship to XB.
Right. But how do you get at that?
You gotta guess a bunch of different XD values and find your XB.
Right up.
And then you gotta do 1 over XD minus XB.
I like that.
And you gotta, that's how you do your Simpsons rule thing.
Yeah, so the problem is this. XD will not be defined, or will not be given to you in the problem. And it is a function of XB, so what you have to do is go to your equilibrium data. You have to find XD as a function of XB, because as XB changes, XD will also change. So I should also note here that you generally be specified number of stages and specified number, your reflux ratio.
So it would take too much time, but guess and check. Do we want to do
Yeah, oh yeah, I think there was a homework problem about that.
Can you do that?
Last semester's class was freaking out because you have to pick a reflux ratio, do all this long stuff, and then if it's wrong, you gotta go back and change again, try again, which is disheartening, but yeah. Well, you'll be given
So,
NRR. So then all you do is you pick an XD, draw your reflux line, step the specified number of stages, 4 stay. Find your XD. We'll call this XD1 and XB1. And then repeat. These have the same slope.
What equation does that have to satisfy?
What's that?
For your guess, so if you guess XD. what-
It doesn't have to satisfy any equation. So all you have to find, the goal is to find a chart that's this. So XB is on this axis, 1 over XD minus XB is on this axis. So you have to plot for different XBs. So for